Hello everyone, my name is Yamini Mittal and I am working as a postdoctoral fellow with the German industry Janisch Schulz. I got this opportunity to work with an industrial organization through a scheme introduced by Indo-German Science and Technology Center. The scheme is known as PDIF, or a Postdoctoral Industrial Fellowship program. This fellowship has allowed me to work with the German industry for a period of 1 year. So basically, I joined Janisch Schulz in September 2023. My host industry is expertised in providing aesthetic wastewater treatment solutions all across Germany, Argentina, Mexico, and Paraguay. In aesthetic wastewater treatment solutions, my industry is basically focusing towards constructed wetlands, which is also known as Pflanzenkläranlage in German. Constructed wetland is one of the conventional wastewater treatment solution and is also known as nature-based sustainable solution. However, in this era of urbanization, they do not fit because they need a large land area for treatment of wastewater. I have been working to resolve this problem of constructed wetland from past 5 years during my PhD time, and we came up with the technology known as constructed wetland integrated microbial fuel cells. In short, they're also known as the WMFCs, and with time they are also expanded as electroactive wetlands. These electroactive wetlands are already been tested at the lab scale, and the idea with this PDIF fellowship is that we scale it up with the help of Janisch Schulz in Germany at 1000 liters. This electroactive wetlands is beneficial in terms of reducing the size of constructed wetlands, and at the same time they can provide bioelectricity as their byproduct. So in the span of 1 year, the results we have achieved with our experiments, we can report that electroactive wetlands are at least 2 times better than constructed wetland in terms of wastewater treatment with the same load of wastewater, and at the same time they can simultaneously produce bioelectricity. So with this success, now Janisch Schulz are trying to implement this technology with their new clients. Now, I would like to say that over the course of my year here, I have gained invaluable hands-on experience from fabricating to operating pilot-scale wastewater treatment plants. This opportunity has also allowed me to witness Germany's strong commitment to sustainability, enriching my professional and personal development. I would like to extend my heartfelt gratitude to IGSTC for this invaluable experience. It has undoubtedly propelled my career forward and deepened my appreciation for Germany's rich culture and high standards of innovation. At the last, I would also like to thank my supervisor in Janisch Schulz, Andre Scheller, who has helped me throughout the reactor fabrication and their working for an year. And in this video, I'll be showing you the wastewater treatment facility which we have right now in Germany. So this is a septic tank from where we are pumping the wastewater out for our pilot plant facility, and this septic tank belongs to this household, which is a 4-people household, and we are pumping the wastewater out through this pipeline all the way to our pilot plant facility. This is our facility. The first one from the left is a constructed wetland for reference, and the second one is an electroactive wetland with granular graphite layers as a substrate, which is a conductive substrate by nature, and the third one is an electroactive wetland with activated charcoal. Again, the substrate is conductive by nature, and the fourth one is electroactive wetland with low cost substrate, which is basically non-conductive by nature, and it's a low cost charcoal. These reactors are having a volume capacity of 1000 liters with a size of 1 meter cube, and this is where we are measuring the bioelectricity produced by these systems. And this is the effluent discharge of the systems, where you can see the wastewater is maintained till this height in all the systems. We have operated these systems at 2 HRTs till now, which is 12 hours and 24 hours. Basically the hydraulic retention time we for 6 months was 12 hours, and for 6 more months it was 24 hours. The influent loading which we have received throughout the year in these systems of COD or organic matter was around 400 mg per liter or 400 ppm. The ammonium loading was 130 mg per liter, and the phosphate loading was 30 ppm or 30 mg per liter. And the effluent received from these reactors are following the standard limits of discharge by all these systems. Here you can see the flow meters which is attached to all the systems, all the 4 systems, and these flow meters allows us to regulate the loading happening in all the 4 systems. And at the end I would like to thank the Janisch Schulz family who has helped me throughout this year for setting up of the reactors and operating them and analyzing the samples, collecting the samples, and also to IGSTC for giving me such an invaluable experience.